Good afternoon, everyone. My name is Dominic Preuss, and I'm very excited to be here today at Google I/O talking about the Google Cloud Platform. I'm the product lead for Google's storage and database products on the Google Cloud Platform. As many of you know, data is everything, and it's at the core of everything that Google does. Whether it be the original backrub algorithm or some of the machine learning things you saw in the keynote yesterday from Sundar, it really is the basis of everything we do at Google. So what we're trying to do is provide that platform that is the best place for you to bring your data to be able to do similar things to what Google's been doing internally. The way that we want to achieve this is by building a fully integrated data platform that is converged and makes it as easy as possible for you to get your data into the system, move it, process it, enrich it, and then derive value from it. We don't want you to worry about where your data ends up or where you decide to store your data. We want to make sure that that data is never in a silo and that it's easy to do what you need to do with it to complete your task. So to achieve this vision, we've built a suite of storage and database products for customers to bring their data into the system. This will give us a little bit of a level set before I dig into some of the later parts of the talk. The goal of this talk is threefold. It's to give you an overview of our storage products. It's to give you a couple of simple reference architectures to give you an idea of how you might build the solution. And then it's to give you a couple of examples of customers that are currently doing this on Google Cloud Platform. So in this portfolio, we'll start all the way on the object store. So Google Cloud Storage is our object store. This is where you put your objects, videos, or data that you're trying to process via different products in the platform. It's used for media serving as well as a collection point for data before you run your data processing pipelines. What's interesting about Google Cloud Storage that's fundamentally different from other offerings is that it is inherently multi-region. So when you put an object into the object storage using our standard class, your data is actually replicated across multiple regions. So it gives you a higher level of availability and ability to serve that data back out to your customers. Google Cloud Storage comes with 3 different storage classes to match your user need. The first one that I mentioned already is standard. The second one is durable reduced availability. And what that means is if you're willing to accept slightly lower availability, we'll give you a better price. And then our third one that we introduced in the middle of last year is Nearline, which basically allows you for 1 cent per gigabyte per month store your data in the same interface and the same product that you would store your more frequently accessed data. Moving on to the relational side, Cloud SQL is our managed RDBMS relational database management system service. So this is where you can go to get a fully managed MySQL database with high availability and pay-as-you-go semantics just like you would if you were rolling it on your own. But instead of you worrying about the problems, you can let Google site reliability engineers worry about those for you. These are really good if Cloud SQL is great if you're building on a framework or have a piece of software that requires a specific piece of software like MySQL, and really makes it easy for you to get up and running with almost no work. If you want to go down the NoSQL path, we have 2 different offerings. One is Cloud Data Store. Cloud Data Store is our application database that allows you to, from scratch, just start storing data. There's no requirements of defining a schema. You don't have to provision size. All you do is start storing your data in an unstructured way. We then make it as easy as possible for you to get access to that data and allow you to scale up to any level. We see this very much used in the mobile and web applications as the default place that people go, especially if they're building applications on Google App Engine. Our other NoSQL database is Cloud Bigtable. So we published the Bigtable white paper many years ago and spawned a lot of the work that's being done in the NoSQL world. We've now taken that internal Bigtable service and externalized it as a service for customers with a HBase compatible client library. So what this allows you to do is to take your HBase and some of your Cassandra workloads and bring them over and start serving them off of Cloud Bigtable in a fully managed way. You no longer have to manage your clusters, your HBase clusters. You can just let Google manage those for you. This is very frequently used in heavy read-write workloads. So we see this in Internet of Things workloads, collecting sensor data, time series databases, and anything that has high throughput and needs low latency reads. Our last one is for caching. So if you have an application in App Engine that you need a caching layer, we provide a fully managed memcache service. So again, this allows you to just use memcache without having to worry about how many nodes is it on, how much storage do you have, how much memory do you have on the node to be able to fit all of your keys, what happens when your keys, if you have to reboot your node. All those things are handled for you in a fully managed service. So now we'll start talking about reference architectures. And I'm going to start with, I'm going to do all of these in two different ways, where we're going to start with the NoSQL world, and then we'll do RDBMS, and then we'll do NoSQL. I don't want to start a religious debate about which is better, so I'm just going to cover both. If you are working in the relational database world, the quickest way to get up and running from your concept of your idea to a megabyte of data is either from your web application or from the web browser client or the mobile client to build your application, deploy it on Compute Engine, and then store your structured data in Cloud SQL and your unstructured data in cloud storage. So this way you can put all of your data that's being generated off of your framework, whether it be Rails or Django or any of the other popular frameworks, and then you can put your static data in cloud storage. Basically, it's a couple of clicks to get these things up and running, and then you can get and start serving your prototype out to a small number of people. Now, if you want to do the same thing with NoSQL, the way that we do this is with those same web and mobile applications or clients, they're speaking to App Engine, which then speaks to Cloud Data Store. Now, the thing that we announced yesterday that we're very excited about is adding Firebase support for Google Cloud Storage. So now those static files that you're saving either from your JavaScript web applications or your mobile applications can be put into Google Cloud Storage via the Firebase set of client libraries. If you were doing this yourself, you write a few lines of code in App Engine to be able to serve that information out, and that data would be stored in Data Store for you. Again, it's replicated, highly available, and allows you to start taking your prototype out to a larger number of people. All right, so you've got your prototype, and you've shown it to a few people, and people like it. So now, how do you push this into production so you can start to support a real number of users? The way that we do this is we would take those same web clients and point them at Google Cloud Load Balancing. Google offers a global load balancing solution. Again, very different than other things that are on the market. And then you would, behind that, put one or many Compute Engine virtual machines to actually host your application. So you'd actually be hosting your code and serving that code out of those VMs. Again, you're serving your data into Cloud SQL. You can have a high availability version of Cloud SQL so that you have high availability, never lose your data, and it's a single click to do that. And again, you're storing your data in cloud storage. So you haven't actually changed anything. You're using the same set of products. You're just provisioning them slightly differently to make sure that you'll scale up to the level of load that you have. Now, if we go back to the NoSQL path, you can see that this is suspiciously like our last slide. And again, you have your web clients and your mobile applications talking to App Engine or to Firebase, and then storing their data in Cloud Data Storing and cloud storage. The beauty of going down this path is that you can scale from basically zero in your concept all the way up to terabytes of data. And all of that happens completely without any intervention on your side. You just keep throwing data at it, and we'll just keep consuming the data. Whether it be in data store or cloud storage, it's a per consumption basis. There's no provisioning. You just throw data at it, and we'll go ahead and store it. Great. So now we've got this product on the market. It's in the App Store. It's doing amazingly well. App's getting slow. We need to really scale this out. How do we support millions of users? So the way that you would do this is, if you're going down the relational database model, is take your web and mobile clients, speaking to the cloud load balancer. Again, no changes are needed on the load balancer. And then you would just be adding additional numbers of compute engines. Now, you can use things like instance groups and some of the other features as well. But to keep it simple, we'll just say that there's a number of VMs necessary to serve your application. And then all of those VMs and those applications are speaking back to Cloud SQL. Now, the one thing we've done differently in Cloud SQL is we've added read replicas. So within Cloud SQL, you can, with one click, add read replicas to basically scale out your read loads. So basically, all of your reads in your application would go to the read replicas, and then you would just send your writes to the master. This allows you to continue to scale on top of Cloud SQL without having to do anything other than add read replicas and potentially change the size of the VM that's hosting your database. The other thing that's is great about the way that we've set up compute engine is that it's very easy for you to add capacity. So if you've attached a certain number of persistent disks, which is our block storage solution, to those VMs and you need to add capacity, you can just increase the size of the volumes without having to restart the machines. We call it hot grow, and it's a way for people to add capacity to their applications without having any downtime. So now I want to start adding in some customers just to give you a little bit of context of how people are using these. So Ocado is a UK e-commerce provider. They basically use Cloud SQL as a way to not have to worry about managing their MySQL instances. They allow Google to do that for them, and they focus on building their applications. Applications that are very transactionally sensitive, whether it be payments or if you have data that it has to always be consistent, a lot of those tend to go down the Cloud SQL path. And so e-commerce and that vertical tends to be very popular with Cloud SQL. Now, if we go back to the NoSQL path, again, this looks suspiciously like our prior slide. Because to go from literally concept up to terabytes of data, nothing has to change in terms of your architecture. As you add more and more clients, both Firebase and App Engine will scale up and to serve those requests, and that data goes into Cloud Data Store, into Cloud Storage, and there's no changes necessary. You can throw as much traffic at it as you want, and they'll just scale up to meet your needs. This is the promise of the platform, where we can just respond to the amount of demand that you're giving us, and you don't have to worry about prepaying for capacity. You don't have to worry about what the pricing does to you. You know that if you use the product, we'll give you your sustained use discounts on the VMs, and you'll only pay for the data that you use in the database. So a good example of going down this NoSQL path is Khan Academy. So Khan Academy uses Google App Engine with Data Store, and we're basically able to scale from a small idea up to a major website without having to make any architectural changes to the way that they build their applications. The goal of all these things is really to allow developers to focus on writing code and not managing their services. So we're trying to basically increase the velocity of development to the maximum by removing anything that isn't delivering value to your end users. So now we start to get into some interesting areas. So now we're going past a terabyte of data. And areas where we start to see large amounts of data is really in the data aggregation space. So there's a number of different ways that you might be collecting data. You might have a mobile client application, which is speaking back to cloud endpoints. So cloud endpoints is our hosted API endpoints that allows you to offload all the management of your API to Google Managed Services. And then the data that's coming in from those endpoints could be written into Cloud Bigtable, which we talked about earlier. Another way is doing the same thing with the web. You have a web application, you're collecting a bunch of stats, time series data that you need to push back to the compute engine, which then gets collected in Cloud Data Store. Again, you're just pushing data into Cloud Data Store. You're not worrying about provisioning. You're not worrying about, do you have enough disk in the cluster? All you're doing is pushing data into Cloud Data Store. And the third one is the one that we're seeing over and over again, and one of the things that I'm most excited about. We keep seeing over and over again people bringing us really interesting data pipelines and ways of aggregating and taking value of their data. So a good example of this is sensor data. So if you have millions of sensors out there that are collecting data every minute, 10 minutes, hour, they have to send all that data back to a single place. What we do is we're seeing people using Cloud PubSub, which is our messaging queue product. It's a global product. It's not zonal. So wherever your sensors are in the world, you can just push your data into PubSub. And then using Cloud Dataflow to then process that data, either in a batch or stream mode, to push that data into Cloud Bigtable. And now we really are seeing people start to operate the same way that Google does internally. So internally, we use PubSub for messaging. We use Dataflow, either usually in stream mode and not batch mode, to then push all this data into Cloud Bigtable. You're now starting to see people really implement their data pipelines and their data collection the same way that we do inside Google, and it's very exciting. One of the things that we did recently that I'm very excited about was a collaboration that we did with FIS. That basically they went and created 25 billion synthetic market transactions, and were able to process them in an hour. And so they were basically able to push from putting data into Google Cloud Storage, processing with Dataflow, putting it into Bigtable. They were able to process those 25 billion transactions in under an hour. And at peak, they were pushing 34 million reads a second and 22 million writes a second using 3,500 nodes of Bigtable. So they were able to do that without having to buy hardware, provision it. We worked with them to make sure that we had the capacity on hand for them to run their test, and then they were able to execute that. And it's something that we're seeing over and over again, that these companies aren't able to run at these levels of scale because of just the procurement cycle that it would be necessary to acquire the hardware to run a test of the size. We were able to spin up in a couple of weeks. So now we've gotten up to a petabyte of data, but it wouldn't be Google if we didn't talk about exabytes of data. So how do you go from having a petabyte of data into an exabyte of data? And where we start to see this type of volume of data is really on the archival workload. So we've got a couple of ways for people to ingest data into our platform. So one way to do this is Google Cloud Transfer Service. So we offer a product that will allow you to grab your data either from another Google Cloud Storage bucket or from Amazon S3 and transfer that data into Google Cloud Storage. We'll do this on a schedule. If there are failures, we'll retry and make sure that all the data gets over, and we'll optimize and parallelize the transfer to make sure that we do it as quickly as possible. Another area that we're seeing a lot of adoption, especially from our enterprise customers, is in the storage appliance space. So we have gone out and worked with a number of the storage appliance companies to partner with them to create integrations for Google Cloud Storage. So companies like EMC, NetApp, Veritas, Commvault. And the idea here is that these customers have several 1, 2, 3, 10, 100 petabytes of data that they've been sitting in a data store that they're paying to buy disks to maintain this data. And so now, instead of storing this on a CapEx basis, where they have to buy these disks, they can transfer it all into Google Cloud Storage using the same storage appliance that they use today and back all that data up into the cloud. And they've gone from a CapEx model where they're paying for actual disks that they have to buy in storage arrays to a pure OpEx model where they're purely paying on a consumption basis for storing that data. We've helped companies save millions of dollars doing this, and it's something that we continue to be very committed to. Another way that you can ingest your data is offline ingest. So we partner with Iron Mountain in North America and Prime Focus Technologies in EMEA and in Asia Pacific. And you can actually send them hard drives, and they will upload those files from the hard drives into Google Cloud Storage for you. So if you don't feel comfortable doing all of that work on your own, we're working with companies to make sure that it's easy and secure for you to upload those files. Now, any talk about storage wouldn't be complete if we didn't talk about our partnership and our marketplace. So Cloud Launcher is where our partners come to be able to launch solutions into the Google Cloud Platform. I've highlighted a number of them. If what you really need is Cassandra, we've got a pre-configured image through Bitnami, one of our partners, to be able to launch up Cassandra into GCE. Same-wise, Enterprise DB, worked with Enterprise DB to get a solution up on GCE so that you can launch these solutions into the cloud so that if we don't provide a managed service that meets your needs, you can manage your own solution on GCE with a single click. MongoDB is another example. A lot of interest in MongoDB. Make it very easy for you to be able to spin up those instances that are running MongoDB to support your workload. Same thing with Redis, very popular caching solution. So we make it one click possible to kick off a VM that is a pre-configured version of Redis. That's all the concepts that I wanted to cover today, but the key takeaway that I want to make sure everyone understands is that we are striving to make Google Cloud Platform the place to store your data in the public cloud. We are faster, cheaper, and more reliable than many of the solutions that are out there. And then we're being fully integrated to make sure that we can actually get your data, move it, process it, enrich it, and allow you to drive value, whether that be through BigQuery or running machine learning models on top of it, like the ones that you saw at Sunder's keynote yesterday. Thank you, everyone.